Okay guys, hello again. Hey, I learned something from that last video. It was way too long. I apologize for that. I'm still learning how to do this, so just hang in there with me. I will start making these quite a bit shorter, and hopefully they stay a little bit more interesting, because even I got bored at the end of that last one. So if you did, don't feel like, oh, physics is not right for me, I hate it. You are still going to love it. We just have to get some of these basic concepts out of the way, and then it gets super interesting and super fun. So let's learn another basic concept today, and that is the concept of velocity. And specifically, we're going to end up talking about speed versus velocity. So that's going to be fun. Okay, velocity. Take a look at these two pictures. You've got a car. That's obviously a fast car. Danny could probably tell you what type of car it is, but I don't know. And here we have like a really slow Sunday drive, like driving Miss Daisy type of thing, okay? So you can kind of tell in general whether something is moving really fast or really slow, but we have to be able to tell from like a diagram of a moving object, right? So how do we tell from a motion diagram? How do we tell velocity from that? So we're going to learn how to do that today. Super fun. All right, remember that uniform motion is motion at constant speed. And which one of these showed uniform motion? It was the skateboarder dude, because he is going at equally spaced intervals, right? So here. So if it were a motion diagram, that distance between successive pictures is equally spaced. Sorry, Danny. Speaking of Danny, he's texting me right now and he's saying, can I have ice cream? So I'm just going to say, of course. The displacement, let's review that concept really quick. So displacement is change in x, and displacement is the final position minus the initial position, meaning this minus this. So that distance, which here is displacement, that is equal between each picture. So we know that he's going at constant speed, and this is uniform motion. If you're looking at a motion diagram and the dots are evenly spaced, right, like that, then it's uniform motion. And that means that the displacement or change in x is the same between each frame. Easy peasy. Here's a motion diagram of a car versus a bike. So here's our x-axis, this black line here, and here I have defined that x is in units of feet. The car is in red, and if we're taking a picture of a car every second, it starts out at 0, here's 0 seconds, and it also happens to be 0 feet. So we defined the origin there. Okay, now in 1 second it went to 40 feet. Then it went 2 seconds, it's at 80, 3 seconds, it's at 120. So what does that tell you? That means that the car is going at a uniform speed because the change in x is the same between each frame. Now let's look at the bicycle. Here's the bicycle. And if you take your pictures 1 second apart, it went from 0 to 20 feet in 1 second. And then 2 seconds is at 40, then 60, then 80. So this is interesting because it is also going, well, I guess it didn't make it to 80. We only did 4 pictures if you count the 0. Okay, so it's also going at constant speed, so it's not accelerating and it's not decelerating, but it's going much more slowly than the car. For the car, the change in x is 40 feet every second. For the bike, its change in x is 20 feet every second. What does that tell you? The car is going twice as fast as the bike. Okay, so can you figure out speed from this? Yes, you can. Okay, let's answer some of these questions. The first question is, which is moving faster? Obviously, we already said the car is. This is graphed as a function of distance, just like before. So this doesn't mean seconds. This x-axis means feet. Let's define speed so we can answer the question, how fast is it going? This one, notice it has a cloud around it. You have to memorize this. Speed is distance over time. Memorize it. Do it now. Speed is distance over time. Distance over time is speed. Speed is distance over time. Do it now. Memorize it. Speed is distance over time. Got it? Okay. Speed is distance traveled in a given time interval, and the time is the time interval over which that distance is traveled in uniform motion. So let's figure out what the speed of the bicycle is. What's the speed of the bike? All right, so first thing I'm going to do, always write the equation. Speed is equal to distance over time. Okay, so speed is equal to distance. What am I going to put for distance? Since it's uniform, we don't have to like figure out too much. So we're looking at the bike right now. What is the distance that it went in 1 second? Well, if we just look here, we can tell that that distance is 20 feet. It went 20 feet in 1 second. So 20 feet. And the equation is the distance traveled in a given time interval, and the time that I'm going to use is the time it took for that time interval. So how long did it take to go from 0 to 20? It took 1 second because we started at 0 second, went to 1 second. So it's 1 second. So the speed is 20, but what are my units? Feet per second. And that's the answer. Bam, easy peasy. There you go. Now let's figure out what does that make sense? That's the last thing we do after we do a physics problem, right? We assess to see if that makes sense. 20 feet per second. Does it make sense that a bike would go 20 feet per second? I mean, who the heck knows, right? We're not speak American here. We do miles per hour. I don't know what 20 feet per second is. So let's figure that out. We have to change feet per second to miles per hour. This is how I do it. This is how you're going to do it. We'll go over it again. First, I need to ask Siri, how many feet are in a mile?
That would be 5,280 feet.
Okay, so now I have all the information I need to solve this problem. This is how I used to always change units, so this is going to be the method I'm going to teach you. We figured out that the bike was going 20 feet per second, but we want it in miles per hour. If a unit is on the top and it's also on the bottom, then we can cross it out and we can cancel them. I have seconds here on the bottom, so I also want to have seconds on the top. So I'm going to put seconds up here, and since I want to change it to miles per hour, so I want the units to be hours, how many seconds are in an hour? 60 seconds in 1 minute. Okay, that's one step. But I don't want miles per minute. I want miles per hour, so I still need hours. Okay, so now I have minutes here on the bottom, so I also want minutes on the top, so it's going to cancel out. How many minutes are in an hour? There are 60 minutes in 1 hour. Now what is going to cancel out? My seconds are going to cancel out, and my minutes are going to cancel out, and I'm going to be left with feet per hour if I do this amount of math so far. But I don't want feet per hour, I want miles per hour. So Siri just told me that there are
5,280 feet.
5,280 feet in 1 mile. Okay, now here's how I convert the units now. If it's on the top, if these numbers are on the top, I multiply them. If they're on the bottom, I divide it, just like a normal fraction. 20 times 60 times 60 divided by 5,280. I can ignore all these ones because that's not going to change anything. But if I did that correctly, my units should cancel out. So I have seconds cancel out, minutes cancel out, and feet, because I have it on the bottom here and I have it on the top here, those cancel out. So what I'm left with is miles per hour. Get 13.6, and my units now are miles per hour. Does that make sense for a bicycle to go that fast? Yeah, that seems reasonable to me. Now, let's go to the next level. Velocity, that was speed. Speed is 20 feet per second. For the car, it's 40 feet per second, which is going to be twice as fast as that. Okay, now let's figure out velocity. Velocity is a vector, just like vector here, right? And it has not just the magnitude of the speed, but also a direction. So if you have speed, but you also have direction, then you have velocity. So the equation that you have to memorize for velocity, which again, you do have to memorize, is going to be a little bit different. Remember that speed is distance over time. Velocity is displacement over time. And remember that displacement, which is change in x final minus x initial. If we have the same type of problem that we did before, going from 0 to 120 in this situation, and we have a bike, this bike is starting here, and 1 second later it's here, 1 second later it's at 40, 60, 80, 100, and then 120. So it's going at uniform speed. Here we have another bike. I wish it wasn't upside down, but it could be. It could be in the upside down world. The bike is starting here. For this, I didn't put 0 seconds, but this is 0, 1, 2. These are the seconds, and bike 1 is 0, 1, 2. So it's going this way, and bike 2 is actually going this way. And this is just telling you like a distance, like you're on a map. If it's graphed as a function of distance, that means it's like you're looking at a map. And bike 2 is starting here and going this way. Bike 1 is starting here and going that way. Okay. The velocities have opposite signs due to opposite directions. Okay. So let's just do this problem. How do we know they're traveling at the same speed? Because they're both going 20 feet in 1 second. This is going from here to here. Bike 2 is also traveling 20 feet because it goes from 120 to 100 in 1 second. It's just a negative 20 feet. So what is the velocity of bike 1? If we use this equation, is going to be x final, and you can just pick any, since it's going at the same speed, you can pick any 2 seconds. x3 minus x2, and it's 3 seconds minus 2 seconds. So if we pick this spot and this spot, it's going to be 60 minus 40, 3 seconds minus 2 seconds. 60 minus 40 is the same as 20. 3 minus 2 is the same as 1. 20 feet in 1 second. Okay, what about the velocity of bike number 2? If we take the same problem and we do 3 seconds minus 2 seconds, 3 seconds is going to be this one for bike 2, right? So it starts out at 60 minus at 2 seconds, it's here, so minus 80, and it's still 3 seconds minus 2 seconds on the bottom. On the top, we're going to end up with negative 20, and on the bottom, we still end up with 1 second. So the speed is the same if you ignore the sign, but the velocity is different, and they have opposite signs because they're going the opposite direction. Easy peasy. So you guys know that already. So speed versus velocity, what is the difference? One of these tells you only how fast it's going. What's that one going to be? That one's going to be speed. One of them tells you about direction. What's that that's going to go under velocity. Which one of these can be positive or negative? Only velocity can be positive or negative, because a speed can never be negative, even if you're slowing down, right? Because it can be 0. It can be like 1 mile per hour, 0 miles per hour, but you can't make your car go negative 2 miles an hour. Time is always increasing. And so the slowest it can go, it can hold still. Does that make sense? So speed is only positive. But if you're talking about velocity, you can make your car go a negative velocity if you define like your house as 0 and you want to go west of the house versus east of the house. One can be a negative velocity, but you can't get there in negative time. So speed can only be positive. Velocity can be positive or negative. In general, if it's a positive velocity, it's going to be moving to the right. Or if it's vertical up and down motion, it's going to be moving up. And that's just convention, just by convention. So far, we have only been talking about average velocity, not instantaneous velocity. So instantaneous means like, what does the speedometer say that I'm going right now? Average velocity means I went from this point to this point and it took me this long. How fast was I going on? Let's go over one more thing. The per. in meters per second, or feet per second, what does the word per mean? So if a car is going, for example, 23 meters per second, that means it's going 23 meters for each second. So the word per means sort of 1 unit of the denominator. So it's going 23 meters for every 1 second, or a certain number of feet for every 1 second. Just as another example, density, we'll talk about this later, but density could be something like 19.3 grams per centimeters cubed. So per means that if you're talking about like gold, the density of gold, that means that there are 19.3 grams of gold for every centimeter cubed. For that much gold, you would know how many grams are in that much gold if you know the density. Okay, cool. All right, let's do a stop to think. And here's the question. Jane starts from her house. I'm going to make a picture because this is what they want you to do. Number 1 step is prepare it, right? She starts from her house to take a stroll in her neighborhood. She walks for 2 hours at a steady pace. What is that steady pace telling you? That it's uniform motion. After 2 hours, she's walked 4 miles. And she's 2 miles from home. Oh, so she didn't do that, what I drew. I'm going to put she's 2 miles from home, but she walked a total of 4 miles. So how do I represent that? She kind of took a path like this. Okay, so she walked a total of 4 miles. Okay, but she ended up 2 miles away from her home. What was her speed? Just one question. What was her speed? So we have to know the equation for speed. Do you remember that? Distance over time. Do we use the 2 miles or do we use the 4 miles? So it wants to know her speed. The speed that she actually walked was 4 miles. The distance that she actually walked was 4 miles. We want to give her credit for all of that because otherwise it would seem like her speed was super slow, a lot slower than it was. So let's give her credit for the whole distance that she went. 4 miles. And how long did it take her? It took her a time interval of 2 hours. So 4 divided by 2, she went 2 miles an hour. She went 2 miles an hour. So that was her total speed. Good job. How would you do it differently if it were her velocity? Velocity is like the total displacement. Okay, you can guarantee, let me tell you how they're going to do AP tests. When they give you a question like this and you get an answer of 2 miles per hour, your choices are going to be A, 2 miles an hour. B, they're going to confuse you by giving you a velocity, displacement, which would have been 2 miles over 2 hours, which would have been 1 mile an hour. You can guarantee that's going to be one of your options because someone else is going to do that. Some other dude, Saudi, some other dude did it, is going to do that. And that's going to be one of your choices, but it's going to be wrong. And you're going to be the smarty pants and get the right choice. Okay, that's all we're going to cover for today. Thanks so much for paying attention. Bye.